Hi guys, welcome to today's recording. We're going to go through the NCEA Level 2 Organic Chemistry 2021 exams today. So let's get into it. So let's have a look at these questions. Question 1, so what are we doing here? Let's have a look. Blah, blah, blah. Two compounds in the above are constitutional isomers, so structural isomers. So with structural isomers, that means they have the same molecular formula but different arrangement of the atoms. So it's kind of like, a really simple way to find your analogy is like if you ever been to like say Toy World or anything, toy shops, and want to buy those Legos, like 3-in-1 Legos, like you can make, using the same Lego blocks, you can make 3 different types of vehicles or machines or whatever. So it's kind of like the same thing. Okay, so what we're looking for here, we're just looking for things that have got the same number of atoms. So clearly this is 6, this is 6, this is 6, this is 4, so definitely not that one. So there's a double bond here, so these two, 3 and 4, can't be structural isomers because when you have an alkene, the number of hydrogen is only going to be double, whereas the alkanes, the number of hydrogen is going to be double the number of carbons plus 2 more. So this is a cyclo structure, and when you have a cyclo structure, the carbon and then the hydrogen number relationship is exactly the same when you have an alkene. So it's going to be compound 2 and compound 3. I mean, you can just manually count, so that will, that's a really easy achieved. If you don't know what you're doing, just literally count it. Okay, so justify your choice. So we have the same molecular formula, so you just need to remember that same molecular formula. That means you have the same number of carbons, which is C6 and H12, but then they have different arrangements. Okay, but number 2 is a cyclic structure. Okay, so here it is, same molecular formula, and then just different arrangement. Okay, so it's very straightforward. Number 2, B. So we got, what's this asking us to do? So compound 3 can form geometric isomers. What's compound 3? So hex 3. Okay, so this is, I'm not drawing the carbon, I'm not drawing the hydrogens out for this one because I'm just going to show you, because this is in the question, I can't be bothered doing the H's. So that's hex 3ing, and they're saying that this can form geometric isomers. So what you need to do with this, let's just put the hydrogens here. You need to redraw this and put your carbon-carbon double bond in the middle. Okay, and then whatever is on the left hand side, you can just do this, CH2, CH3. And then on the other side, because we're looking at cis, so we want the H's to be on the same side, and then the CH2, CH3 is on the same side, and that's your cis isomer. And then the trans isomer is just when the H's and CH2, CH3s are on the opposite side. Okay, so I'm just drawing them like that, CH2, CH3. So it's very important that you can understand what cis and trans or geometric isomers means. So the key thing is you must have a double CC double bond. Okay, so that's bullet point number 1, because that does not allow free rotation around the carbon-carbon double bond. And then the 2 groups bonding to the carbons that are in the double bond, let's say XX, YY. So if you look at one side, these 2 things must be different, these 2 things must be different. And when you have the same things on the same side, that is when you have a cis isomer. Okay, so let's have a look at the answers here. So you must have a carbon-carbon double bond, which means it does not allow free rotation. And when you must have different groups of atoms bonding to each of the carbons in the double bond. So it's very straightforward in that regard. But this is like a guaranteed excellence question. So it takes definitely pays to study these cis and trans isomers thoroughly for this particular section. All right, next one. It's just very predictable questions. So and I always mention that probably if you want like a more thorough explanation, just go through the playlist, have a look at the 2018 exams that I've done a few years ago. Though in those ones I've done them in much more detail, like giving you more thorough examples and breaking it down a little bit more thoroughly. but yeah, just doing them. I already done it once, so you can just have a look at the 2018 exams. Okay, next one. So they both react with hydrogen bromide. In one case, two products are produced. The only one organic, while the other only one organic product is produced. Okay, so it just means this one react with HBr, this one react with HBr. Okay, so this is the type of reaction. So we got addition reaction, and whenever you have a double bond, like this is what I mean with when people struggle with organics and they say, oh, it's so much to memorize, you know, why do I have to memorize everything? Well, you can be smart about it, and you're just trying to understand what we're trying to achieve here is that with organic chemistry, all the functional groups must react first. So it's always like, say, for example, the double bond. You know, what's going to happen to the double bond? It's obviously going to break. Okay, so when this breaks, so you're breaking the double bond, and then you add new atoms onto those two carbons that are no longer double bonded. And then for the first one, why are there two products? It's because if you think about this, if we break this double bond, let me get the rubber. Actually, let's not get the rubber. Let's do it this way. And I just do it like this. Just break the double bond and copy everything else. And when you do chemistry, if you guys do year 13 chemistry next year, you're gonna do, when you watch my year 13 videos, you're gonna hear me saying this even more. Just understand what we're doing and just copy paste. A lot of it's only the functional group that does something, and the rest is just copy paste. Okay, so here we've broken down everything. I'm just gonna put, so what are we adding? We're adding HBr. So that means we can add the H here, put the Br here, because we broke the double bond. Don't put the H and Br anywhere else. And then vice versa, I'm gonna put the Br here, put the H here. And which one's major? This one's major. Why is it major? Because this carbon has two hydrogen compared to this carbon, so it's more likely for this carbon to gain another hydrogen, and hence it's major. Don't say rich gets richer as in part of the explanation. It is a law of economics. It's not it's not a law, it's common sense of economics. It's not you can't just say, oh, this one's major because rich gets richer. You actually have to explain the explain what's actually, why it's being added to the carbon, because it already has more H's. Okay, so this is major minor products. And then this one, for compound 3, you're not gonna get major minor products because the alkene is symmetrical. Okay, so that means you can put the H here, you can put the Br here, or you can put them other way around, but that doesn't change anything. It's still going to be the same thing. Okay, so the symmetrical aspect is gonna come in place. Okay, so let's have a look at the answers. All right, addition reaction, because you break the double bond, you're adding new atoms. Okay, compound 1 is you make two products because it's asymmetrical, and so two possible positions. And then look here, so we don't say rich gets richer, so the carbon of double bond with the most hydrogen attached will gain another hydrogen to form the major product. Okay, and so hence the other one is a minor product. And for compound 3, only one product because the alkene is symmetrical, so you only make one particular product in this particular example. Okay, all right, moving on. Flowchart. Okay, so flowchart, this requires you to understand the reaction chain. And again, people have always asked me, if I memorize a flowchart, can I do well? Well, not necessarily. You have to understand the flowchart to know what you're doing here. And because the thing is, if you don't know the flowchart, you definitely don't do well. But if you just memorize the flowchart and don't understand how to use it, then that doesn't help as well. And especially with some of the flowcharts that you might be given from your teachers, personally, I stopped giving those flowcharts, those generic flowcharts, like say alkene turn into alcohol, alcohol turn into carboxylic. I don't give those anymore. You want to start with something like what you see on the screen, something specific. Okay, like if you can, and this is something I always recommend people to do, like start with this one. This is a good one. Start with butane. Can you turn that butane into a 1-chlorobutane or 2-chlorobutane? Can you turn the butane into butanoic acid? How do you turn the butane into butanoic acid? How do you turn the butane into butane 1,2-diol? It's all, start with an alkane in the middle and see if you actually understood the flowchart. So from here, I'm just going to do everything here. So we're going from, this is alkene to, so clearly you can see we brought the double bond, we added H's. So this is going to be H2/platinum for nickel. Depends on which one you go with. I always go with platinum. And then from this one to this one, you're going from, so this is going to be a substitution reaction because you replaced, oops, I don't want to rub out those. You replaced one of the H with the Br. So this is a substitution reaction, so you would have used Br2/UV light. You have to put UV light here because that's definitely required. And then from this to with NH3, so you simply replace the Br with NH2, not NH3, because your nitrogen only bonds 3 times. If you put NH3 here, then that's going to bond 4 times, which is incorrect. Okay, now let's have a look at the next one. So from the amine to what is this? So this is, so remember amines are alkaline, so they are bases, and then this is clearly something to do with acids and base. So this is HCl, because HCl is an acid, and the acid will neutralize the base. So what is the base? What does the base do? The base will accept the H plus, so it becomes NH3 plus. And then the Cl is just going to stay around as minus. Okay, so Br, from looking over here, Br KOH AQ. When it's AQ, you simply replace the Br with an OH, and everything else stays the same. And then when you do the, when you turn the OH into butene, this is using a elimination reaction. So you use concentrated H2SO4. Okay, so and last one, and compound H. So again, you break the double bond, and then you know, just always break the double bond if you have an alkane, alkene, and then put the Cls onto there because you're adding 2 chlorines. Okay, so that's pretty much, you know, these questions. I just done them on the thing. Oh, forgot one thing. This reagent Y. Reagent Y. What are we doing here? So you're turning this into the alkene. Wait, isn't that the same thing? Oh wait, this goes here, right? So reagent Y is conc H2SO4, so it's the same thing. Okay, so this is purely based on your understanding of organic chemistry in terms of the flow chart. Is a guaranteed excellence question. So you know, you just have to know how to do these. There's no other way around it. Okay, so that's all of that. Next one, refer to the reaction scheme, blah blah blah. Why do I need to refer to it? It's right here. Okay, so I just need to draw 3 repeating units. So this is the thing that, again, people tend to struggle with. Whenever you're dealing things with alkenes, when you're doing system trans isomers or polymerization, always put the double bond in the middle and then go up, down, up, down. You know, this way you can clearly see what we're trying to achieve here. Oops. Looks really ugly. Come back, CH2, CH3. And when you do 3 repeating units, just draw 3 of them. Just draw 3 of them side by side. Note that I didn't connect the double bond, because I'm gonna get rid of that in a sec. It's just literally a copy and pasting activity. Okay, you know how these were double bonded? You know, these are 3 individual atoms right now, and then during polymerization, what's going to happen is that they will break the double bond, and then you connect everything together, and then this will repeat it n times. Okay, very straightforward. Just centralize your double bond and go from there. Compound A cannot undergo addition polymerization. Of course not, because it doesn't have a double bond. So of course that doesn't undergo polymerization. So you need a carbon-carbon double bond, and you need to break the double bond in order for these atoms to connect to something else. Okay, so polymers are just repeating units of monomers, whereas monomers are just simple building blocks that gets repeated. Okay, so if we look at link this to the reactivity, so the double bond definitely is more reactive because it has a double bond. You know, so you can break, And then some people talk about, I think the answers as well, this is what we call unsaturated. Unsaturated means is that you can bond more, you can add more stuff. It's not full yet, so you can break the double bond, you can add more things into the atom, into the molecules, hence it's unsaturated. Whereas this one is saturated because you can't add anything to it. Okay, so let's look at the answers here. So in addition, polymerization, you have to break the double bond in order for new bonds to form, and then polymers are just long chain repeating units. Okay, so this is the alkene is unsaturated. So it's, you know, you have the double bond which can do this, and then the other one is saturated and it doesn't have the ability to, you know, to do what we ask them to do. Oh, it's very bizarre that to put the naming here, because normally they put it right at the top. Okay, so what is this? This is a amino ethane. You can call one amino ethane or just amino ethane because it's nowhere else it could be, has to be one. Or you can call this ethanamine. Doesn't matter, either one's correct. 2,2-difluorobutane. Now with the naming, always go backwards. So start this way, you know, from the right. So but, 4 carbons, butane, difluoro. So we got 2 F's. Where are they on the second carbon? 1, 2. And then make sure that every single carbon has got 4 bonds. Okay. 3-methylbutanoic acid. So again, butanoic acid, but 1, 2, 3, 4. Oic acid means you have a COOH in the end. 3-methyl, this is 1, 2, 3, 3-methyl, and then make sure every single carbon have got 4 bonds. Okay, and then last one, this is look at the longest chain, that's 5, so that's pentane, and then this is an ethyl group. Now where is the ethyl group? This is 3-ethyl pentane, or we can just call it ethyl pentane because it can't be anywhere else. All right, so that's that one. Now complete the table classifying each. Okay, so this is where you need to look at the OH. The OH is bonding to a carbon that's only bonding to one other carbon, so this is primary. This OH is bonding to a carbon that's bonding to 1, 2, 3 carbons, so this is tertiary. This OH, this Cl is bonding to C, which is bonding to 2 other Cs, hence this is secondary. The OH is bonding to C, which is bonding to 1 other C, since this is primary. Okay, so difference in classification is just looking at how many carbons that it's bonding to the carbon that's bonding to the OH. So you can see here the OH group is bonding to carbon that's directly bonded to 1 other carbon, so it's primary. And then the hydroxy group bonding to 3 other carbons, bonding to a carbon. You know, the carbon that has this OH group is bonding to 3 other carbons, making it tertiary. Okay, so it's like a very easy mere equation. Oh, distinguishing case. Okay, so how do you distinguish the following? So what have we got here? So you have to read it very carefully. So you only allow bromine water, so it's bromine aqueous, or aqueous potassium permanganate. The aqueous part is really, really important, guys, because people don't underestimate the aqueous bit. The aqueous bit means there's a lot of water. All right, just make it clear. There's lots of water in there, so you can actually use them to look at solubility if you need to. So you know, it's not necessarily required, but then sometimes they give you something that's aqueous or it's a solution, and then they give you something like an alkene and a carboxylic acid, and you're like, wait, none of these will react with these reagents, but they will dissolve differently. Well, they have different solubility in this in this water solution, which is polar, so only the carboxylic acid, you know, just as an example. Okay, so this is propan-10 3-chloro-pentane, so this is going to react with this guy, because your propan-10 is going to be oxidized by the MnO4- /H+. This will turn into the carboxylic acid. Now in the process, this guy will go from purple to colorless, and this is an oxidation reaction, and the other guy doesn't react. Okay, so here it is, exactly the same thing as I did. So it goes from purple to colors, you know, the reaction, you know, something along the line. This one here, propan-10 and pent-1ene. So with this propan-10 and pent-1ene, What are the reagents again? So one is, okay, so whenever you see bromine water, where are we again? Bromine water, here we are. When you see alkane, straight away bromine water. Okay, because when you have the bromine water, again, I can't be bothered doing the H's, you guys can do the H's. What happens when you add bromine water? You break the double bond, and then the BRs get over here. Okay, and the BR2 is orange, and this will, oh my god, I can't spell this morning. This is orange, and this will turn colorless straight away. Okay, and this guy doesn't react. All right, so if you look at here, exactly the same thing. Pentwinning, add the bromines, and the other one will not react. Okay. Last one, nope, this is part C. Devise a procedure that you could use to distinguish between ethanol, propanol, pentwinning, using only the physical properties. So that's limited to melting point, boiling point, or solubility. Okay. So when you think about these, is that the when we do chemical distinguishing tests, we're looking at chemical reactions. When you do physical distinguishing tests, you're looking at the things that we just highlighted. Okay, so the first thing that you can straight away look at is that these two are polar, and this one's non-polar. Okay, so straight away with solubility, add water. Okay, so you're gonna add water, and when you add water, that your alkanes, your haloalkanes, they're not gonna dissolve. Okay, so add water, and then this guy will be insoluble. So you have two layers, whereas the other guy has one layer. Okay, and then you have these two left, and then your propanol is that this guy will have a higher melting point or boiling point. Okay, so it has a higher melting point or boiling point because it has more carbons. Okay, because it has more carbons, so you can, you know, boil the two until see which one turns into a gas, and then the one that has a higher boiling point is going to be propanol, the one with the lower boiling point is ethanol. Okay, so let's have a look at this. So same thing, pentane, water, and then we slow heat, and they'll turn to gas, and one with the lower boiling point is ethanol because it has less carbons. The more carbons there are, the higher the melting point and boiling point. Okay. All right, let's go. I think this is the last question. Last question? Yes, last question. Right, lucky last. So we got KOH. Yes, this is one of the popular questions. Chloropentane can undergo two different types of reaction. So just remember, KOH-AQ is substitution. KOH-ALK is elimination. And I always use this example so to help people remember it. You know, like when it's alcohol condition is when people, you know, when you get drunk, you lose stuff. So elimination. Okay, so you lose stuff, eliminated. When you drink a lot of water, that replaces your body fluid, so you need to go to the toilet quite a bit. So that's substitution. You're replacing the body fluid. I don't know. That's how I tend to remember it. Okay. So if you have 3-chloropentane, which is this thing right here. So if you do KOH, you know, AQ. So all you've done is that you just replaced, you know, write your hydrogens, guys, don't be lazy like me. You just replace OH. So that's a substitution reaction. If you do a KOH alcohol, and what that has done is that you're going to delete one of this H. You're going to remove the Cl and one of the neighboring H's. And in this case, because this one is symmetrical, you don't make major minor product. Okay, so it doesn't make any difference where I put the double bond. So you lose a Cl and lose this H, and you double bond here. And this is your elimination reaction. Okay, so just remember, alcoholic KOH, elimination reaction. You lose a Cl and the neighboring hydrogen, and you make a double bond. And whereas for the other one, 3-chloropentane would react with KOH, pentane 3O is formed because it's a substitution reaction. Okay, so I think these year 12s last year had it pretty easy. I mean, I'm recording in 2022, but I think this is a very fair paper. No questions in there that are like totally new or undoable. So yeah, very nice paper to do. Okay, so hopefully this has been helpful. So leave a like and subscribe if you haven't, and I'll see you guys next time. Bye bye.